Two spheres A and B, with masses 6 kilograms and 2 kilograms respectively, move towards each other on a smooth horizontal surface and collide directly. Just before the collision, the speed of A is 7 and the speed of B is 3. Immediately after the collision, both spheres move in the same direction, with the speed of B being twice that of the speed of A. Show that the speed of B immediately after the collision is 7.2 meters per second. Determine the coefficient of restitution between the spheres and find the magnitude of the impulse exerted by sphere A on sphere B in the collision. So let's have a look at this then. So I've drawn the picture of the information and summarized the question. The speed of A is 7, the speed of B is 3, and they're heading towards each other, of masses 6 and 2 respectively. After the collision, the speed of B is twice that of the speed of A, so we put 2v here and a v here. So let's have a look at B's speed after then, by considering the conservation of linear momentum. So conservation of momentum then gives, using this principle, it gives, well before it's 42 in this direction, so we're going forwards. Forwards, take away 3 times 2 is 6, that's the momentum before, is equal to 6v after, plus another 4v here when you do the product. So that tells us then that 36 is equal to 6 plus 4 is 10, 10 lots of v, so v is equal to 36, move the 10 from times to divide, 36 over 10 is 3.6. So there's the velocity. So B's speed is, well if we look at here it's 2v, which equals 2 lots of 3.6, which is 7.2 ms minus 1 meters per second other units. So there's the speed of B after. Determine the coefficient of restitution. So B, so here the coefficient of restitution, which we label customarily as E, is equal to the speed that they're going together afterwards, 2v minus v, divided by the speed that they went together at. 7 plus 3 is now, which is equal to v over 10. V is equal to 3.6 over 10, which equals 0.36. So that's the coefficient of restitution. See the impulse exerted by A on B. So the impulse is equal to the change in momentum. So the momentum after was 4v. Take away the momentum before, we're going in this direction. So it's 4v forwards, take away, and it's the momentum backwards, which is going back 6, so it's minus 6. So that makes that a plus 6. 4v, v is 3.6, 2v is 7.2, so this is 14.4. Type it in the calculator if you need to, plus 6, which is equal to 20.4 Newton meters, I think, is the unit. I'll have to check that, but it's 20.4 is the answer. It's not Newton meters, I just reminded myself it's Newton seconds because the impulse is change in momentum. So we'll put Newton seconds here. 20.4 Newton seconds.